We're going to talk about when functions are increasing or decreasing. Actually, the methods and the ideas that we're going to talk about in this section are actually going to continue. This is the beginning of sort of a big unit about increasing and decreasing functions and related ideas. Increasing, so let's first talk about on a graph. This is easy to identify. Let's say a picture like that. When I say increasing versus decreasing, this particular function that I drew here, sometimes it's increasing and sometimes it's decreasing. And what I mean by increasing or decreasing is it going up as you go to the right, or is it going down? And sometimes it's going up, sometimes it's going down. So increasing means the graph is going up as we move to the right, and decreasing means the graph is going down as we move to the right. And a typical function is going to be sometimes increasing for certain places and it's decreasing in other places. This function, for instance, is increasing, say, along this area. There is increasing, right? It's going up as you go to the right. And also in this region is increasing, right? So increasing for this function would be here and here is where it's increasing, and it's also decreasing sometimes, actually the other time. So it's decreasing right here and also right there. All right, so when you're looking at a picture, it's easy enough to identify where are the places the function is increasing or decreasing. It's just, is it going up or going down? Here's another example of a function. I want to just be a little more specific here. Can we say, this is a typical problem you will encounter, give intervals. Give intervals where f of x is increasing and decreasing. So where is it increasing and where is it decreasing? You look at the picture, you just decide where is it going up as you move to the right, where is it going down. But you want to express those answers in terms of intervals. One thing you want to notice is these points, which I'm going to put dots on, these are important when it comes to questions about increasing versus decreasing. Sort of the little mountain peaks here, and also these little valley points where it sort of goes, hits rock bottom. Those are important points, right? To demarcate the regions where it is increasing versus the regions where it is decreasing. I want to give intervals of x values where the function is increasing and decreasing. I'll say it this way. It's increasing on the interval. I have, for instance, this interval here, it's increasing. Also this interval here, it's increasing. And this one over here, it's increasing. Let's just say what they are. I want intervals of x values. So this one here is the x value 1. And it's all the numbers less than 1 and up to 1. It's increasing. So as an interval, that would be written this way. The interval minus infinity to 1. That means all the numbers over here up until you get to 1. I'm using the curved parentheses here rather than the square bracket because actually it is not increasing at this point 1. This point 1 is like a special point where it's not increasing or decreasing at that particular point. So it is increasing on the open interval, minus infinity to 1. It's also increasing right here, which as an interval I would write, this is the interval from 3 to 5. So I'll say and 3 to 5. And also, along here, what's the x value here? 1, 2, 3, 4, 5, 6, 7, 8. 8, and everything up, higher than that, it is increasing. So this would be 8 to infinity. All right, let me just emphasize. Here I'm talking about the x values. Intervals of x values. Don't look at the y values when I ask you a question, give intervals where it's increasing or decreasing. I mean intervals of the x values where this function is increasing or decreasing. And what about decreasing? On the intervals, so it's the same, only I'm only going to write down the ones where it's going down. That would be here, 1 to 3. And here, 5 to 8. 5 to 8, right? 5 to 8. Next, I want to talk about how could you do this for a function which I just tell you the equation of. You don't see the picture. Can you still tell me where is it increasing or decreasing? You can actually. You got to find these points first of all. Those points, though, I will have you remember, They are places where the derivative is 0. That's what those points, that's what causes those points to look like that. It's because the derivatives are 0. And can you say, what about increasing, decreasing in terms of derivatives? Well, increasing means the derivative, which is the slope, is positive, right? It's going up. Versus decreasing, the slope would be negative. So this is how you tell. This is how you tell when something is increasing or decreasing. If you're just looking at formulas, increasing means f prime of x is positive. Decreasing means f prime of x is negative. And then those points in the middle, sort of between one interval and the next, those would be where the derivative is 0. And the switches, I mean when it goes from being increasing to decreasing or from decreasing to increasing, the switches happen when f prime of x equals 0, right? If the derivative is positive sometimes and then it changes to being negative, the only way that can happen is if it's 0 in between, right? So the switches happen when f prime of x equals 0. Actually, there is another technical case, or it is possible also that it could switch from positive to negative when the derivative does not exist. So the only way for it to be positive and then become negative is, in one case, if it goes through 0. That's the usual way. It's also possible that the derivative could not exist, like it could go off to positive infinity and then afterwards become negative infinite. If the derivative does not exist. Usually this doesn't happen. But anyway, there's a word for this, such values. So I'm going to say values of x, where f prime of x equals 0, or f prime of x does not exist, are called the critical numbers. The critical numbers. So our strategy to figure out where is it increasing or decreasing, first we find the critical numbers. These are the points where it switches from being increasing to decreasing. That'll give us some kind of framework, like these are the points where it switches, and then in between those points are the intervals. And how do you tell in between on those intervals whether it's increasing or decreasing? I'm going to say the second step for doing this is plug values into f prime in between. I'm not explaining this much at this point, but it'll be clear in context when we do this. I want to do two examples. One is pretty easy. One is, a little less easy. All right, give me intervals where this function is increasing or decreasing. F of x equals 3x squared minus 6x plus 8. Okay, first, find the critical numbers. Remember, that means places where the derivative equals 0 or the derivative does not exist. So you should begin by taking the derivative, f prime of x. This is easy enough in this case. I do the derivative, I get 6x minus 6, right? I want to know when is the derivative equals 0. F prime equals 0 is what I'm trying to figure out. Well, you set this equal to 0. So I go 6x minus 6 equals 0. And then solve for x. You would add the 6. 6x equals 6. Divide the 6. X equal 1. This is a critical number. In fact, it's the only critical number. This is the only place where the derivative equals 0. We should also think about when the derivative does not exist. That's also a possibility for a critical number. But this derivative here has no denominator, which might be 0 or something like that. This derivative always exists. So I'll just say f prime always exists. So f prime dne is impossible. So we don't have to consider critical numbers of the form when the derivative does not exist. Okay? This is our critical number. That means, actually, you can say at this point what the intervals are. X equal 1 is the single point at which it switches from being increasing to decreasing, or maybe decreasing to increasing. We don't know yet. But anyway, that means the intervals are minus infinity to 1 and 1 to infinity, right? That point, x equal 1, is the place where it switches from being increasing to decreasing, or maybe decreasing to increasing. We don't know which is which, but we do know the two intervals must be those two things. How do we figure out on which of these is it increasing, on which of these is it decreasing? I like to make a little chart. Here's a little chart. It's going to be a chart of the signs, like positive versus negative, of f prime. And here's what I'm going to do. I'm going to indicate certain x values. The important x value is x equal 1 in this problem. And then down here I'm going to try to indicate values of f prime being the signs, positive versus negative. Now, we don't know if it's positive or negative on various... This is like meant to represent the number line. And I have marked off the number 1. Over here would be numbers greater than 1. Over here would be numbers less than 1. And as far as the derivative concerned, the derivative equals 0 right there. That's how we determined this point, x equal 1, was it is the point where the derivative equals 0. My question simply is the derivative positive or negative over here? And is the derivative positive or negative over here? Here's where we do the second step. Plug values in to f prime of x in between. So we are going to just choose some value in each of these two intervals. What I meant by in between is a typical example, you get more than one of these points. And you have to choose values in between the various regions. Here we only have two regions and they're not really in between anything, but that's what I meant by in between. Choose some value in this region over here, your favorite number greater than 1, and then also choose your favorite number less than 1, and plug them in to the derivative. So I'm going to choose a value over here and plug it into the derivative. What's my favorite number greater than 1? I'm just going to choose 2. You could choose any number you like greater than 1. You might as well choose one which is like easy to plug into things, right? What is f prime of 2? I hope you remember. I erased it, but f prime in this example was 6x minus 6, right? Hopefully you still got that on your paper. So what is f prime of 2? You just plug that number into this formula. 6 times 2 minus 6. That would be 12 minus 6, which is 6. This number is not so important. What is important is that it is positive, right? Positive. And so on my little chart here, I'm going to put a big old plus sign over there. That means all these values to the right are going to be positive. We know they are positive at x equal 2, and we also know it doesn't change anywhere in here because there are no other critical numbers over here. So it must be positive everywhere in that region. What about to the left of 1? What's your favorite number less than 1? I'm going to tell you my favorite number less than 1 is 0. You should always use 0. 0 is typically very easy to plug into various different functions. My favorite number less than 1 is 0. F prime is 0. I plug in over here. 6 times 0 minus 6 is negative 6. This is negative. And so over here, that is a big minus sign. All right? We're basically done at this point, ready to say the answer. The intervals are these. Remember, the only question left was which one is increasing, which one is decreasing. And we have decided the derivative is negative on this one, which means it's decreasing. The derivative is positive on this one, which means it's increasing. So my conclusion, I'm out of room here, but I'll write it up here. So we say f is increasing on the interval 1 to infinity. That's this one. And it is decreasing on the interval minus infinity to 1. That's this one over here. All right, that's how we do it. Let's try one more example that's a little more complicated. All right, same question. Give me intervals where this function is increasing or decreasing. Here's the function, x to the 4 plus 4x cubed plus 4x squared plus 1. We're going to do the same thing. The first step was find where the derivative equals 0, f prime of x. So you're going to find f prime of x and then set it equal to 0. So first of all, f prime of x, this is easy enough. I go 4x cubed plus 12x squared plus 8x, right? That's just a derivative of a polynomial, easy enough. Now in problems like this, it will be to your benefit if you simplify this as much as possible. I always say, no need to simplify unless you have a good reason to. Because you're going to be using this formula over and over again for the rest of this problem, it would be a good idea to simplify as much as possible. How can we simplify this? One thing is you can factor a 4 out of everything. In fact, I can factor 4x out of everything, right? I'll do that. What remains would be x squared plus 3x plus 2, right? And now, actually, we can continue. We can factor this. 4x out here. What are the factors of that? They have to multiply to be 2 and add up to be 3. I think they're 1 and 2. So x plus 1, x plus 2. All right, this is f prime of x. I'm going to put this sort of in a little box. Squeaks. We're going to be using that throughout the rest of this problem. So don't forget about that. F prime of x is 4x times x plus 1 times x plus 2. Okay, what about the critical numbers? That's when the derivative equals 0 or the derivative fails to exist. First of all, this derivative always exists. The only way it could not exist if it had like some places where the 0 in the denominator or something. None of that in this example. So the derivative always exists. When is the derivative equal 0? Well, you set this thing equal to 0 and solve for x. So 4x, x plus 1, x plus 2 equals 0. Solve for x. How do you solve for x and something like that? Well, it's already factored. And once it's factored like this, you know, you have 3 things. They multiply to be 0. That means one of them is 0, or the other one is 0, or the other one is 0. So you break it up. 4x is 0, or x plus 1 is 0, or x plus 2 is 0. And we're going to get several answers in this one. This one gives me x equals 0. This one gives me x equal minus 1. This one gives me x equal minus 2. These are our critical numbers. What do we do next? Remember last time? We make a little chart which has those critical numbers labeled along the x-axis. All right, I got my chart. I have labeled the critical numbers. There were 3 of them. Minus 2, minus 1, 0. Make sure you put them like in order. This is supposed to be a number line, so put them in numerical order. That's our derivative, which we're going to be using as we go along. What do we do next? Remember, we need to determine on these. So I have 4 intervals here, right? There's this one, this one, this one, and this one. They're the regions in between the critical numbers. We need to determine on each of those 4, is it increasing or decreasing? We do this by plugging numbers in between here and plugging them into the derivative. So sorry, I should have put zeros here. Those 3 are the places where it's 0. My next job is to fill in between positive versus negative. And I'm just going to plug numbers in. So choose your favorite number less than minus 2. I might as well use minus 3. All right. I'm also going to choose my favorite number between minus 2 and minus 1, which I guess is minus 1.5. Between minus 1 and 0, I suppose I'll have to use minus 0.5. And then greater than 0, I'll use 1, right? You want to choose numbers which are going to be fairly simple to plug into that formula. What about it? Minus 3. Okay, plug in here. I get 4 times minus 3 times minus 3 plus 1 times minus 3 plus 2. Now, you could plug all of this into your calculator, but I'm here to tell you, you don't actually need to use your calculator for this. And as you know, on our tests and quizzes or whatever, I will not allow you to use a calculator. So how can you do this without using a calculator? It's not so hard. Here we have a bunch of things which are multiplied together. And I don't care what the answer is. I only care if the answer is positive or negative. All you got to do is look at the various parts here. I have 4 things, right? The first one is a positive. So would you mind if I write it this way? I have a positive times a negative times this. Minus 3 plus 1, that is minus 2, which is a negative, times the last thing. Minus 3 plus 2, that's minus 1, which is a negative. So whatever this is, I have a positive times a negative times a negative times a negative. There are 3 negatives there. That means the answer is negative, which means in this interval, I have a minus sign. That's a big minus sign there. All right, and we're going to do the same things for the rest of them. 4 times, okay, this time I have negative 1.5. Okay, minus 1.5 plus 1, minus 1.5 plus 2. All right, and this time I got positive times, that's negative, times, this, is that positive or negative? Negative 1.5 plus 1 is still negative. And then times, finally, negative 1.5 plus 2, that's positive, right? So here I have a positive times a negative times a negative times a positive. There's 2 negatives, that means this is positive. And so I'm going to put a big old plus sign here. We just do the same thing for the others. Don't need your calculator, son. All right, I plugged in negative 0.5 to those guys. I get a positive, a negative, a positive, a positive. And this ends up being negative because there was only one minus sign in there. So negative right there. And finally, this is the easiest one. 4 times 1. 4 times 1 times 2 times 3. These are all positive. So this is positive, positive. All right, we're pretty much done with all the work. We can just say our answer at this point. It increases when these are positives and it decreases when these are negatives. So I'm going to say f is increasing on the interval -2 to -1. And over here, which is 0 to infinity. And it's decreasing on the interval over here, -infinity to -2. And here, -1 to 0. That's the way.